Hello, this is Miss Charlotte from Arch Education. Today I'm going to teach my lesson in IB chemistry, and I will focus on organic chemistry in today's video. So here are some topics I'm going to go through in today's lesson. So let's get started with naming alkanes. So actually there are a few rules we need to remember when we name alkanes. So the first rule is we need to find the longest carbon chain in the molecule. We need to choose the prefix corresponding to the number of carbon atoms in the longest chain. And then if this is a single bond, we need to add ANE. Okay, if this is a double bond, we need to add the name ENE. And if there's a triple bond, then we need to add YNE. So here is the code right here. So for example, if there are 5 carbon in the longest carbon chain length, then I will write pent. And then we need to figure out whether it's single bond, double bond, or triple bond. And then we need to write ANE, ENE, or YNE. And so step number 3 is, so after you determine the longest carbon chain length and then you find the code, and the third thing we need to do is we need to look at for any substituent group. So for example, if there's a substituent group, then we need to number the position of the substituent group, and we also need to use the prefix right here for the substituent group. For example, if there is CH3 group, then we need to write methyl. So let's do this example together. The first what we need to do is identify the longest carbon chain length, which is right here. And I can see there are 5 carbon, which is the longest chain length here, and 5. So that means the name for this should be pent, P-E-N-T. Okay, so since there is no double bond or triple bond, and all of them are also only like single bond, so we will need to write ANE instead of ENE or YNE. So remember, ANE means single bond in the structure. Okay, so the next thing is we need to look for, is there any substituent group? And as I can see right here in the structure, there's one CH3 group, and CH3 group attached to this carbon, and this is what I call a substituent group. And in other words, because there's only one CH3 group, and so I will write this as a methyl group. So I will write methyl in front of pentane. Okay. Now, finally, the last step we need to do is we need to write the position number. Like for example, where is the substituent group? So as you can see, the substituent group is located in carbon number 2. So therefore, I will write 2 hyphen. Yes, and so the name for this example will be 2-methyl pentane. Now, let's talk about alkanes, alkenes, and alkynes. So as you can see, alkane in this structure is there's only single bond, and so I will use the name ANE. And for alkene, that means you will see a double bond in the structure, so therefore I will use ENE. And finally, YNE will be the structure that contains a triple bond. And then the next topic I want to go through is functional group. So functional group, for example, we have aldehydes and ketones. So these two are what I call carbonyl compounds because they contain CO double bond for aldehydes and ketones. And for carboxylic acid, it will be COOH. So that means, for example, if you see the structure and there's a COOH bond there, that means this is a carboxylic acid. So when you see there is some functional group appears on the structure, then that means the name will be a bit different. We won't write as ANE, ENE, or YNE anymore. We will write something special. For example, for aldehydes, you will see AL. So that means for the name, I will also write AL. And for ketones, because ketones, ONE. So after I name the structure, I will write ONE at the end. And for carboxylic acid, we will keep this part. So we will keep OIC, and then we will also keep the word acid here. After we find the longest carbon chain and the substituent group, then we will change the end part to OIC and then acid. So here are some rules for naming the functional group. Okay, so this is a chart where you can see I also add one more functional group here, which is alcohol. For alcohol, this is a OH group. And for carboxylic acid, there will be COOH. Aldehyde, there will be CHO. And finally, ketone will be a double bond with like CO double bond. So the next part, I want to focus on alcohols. So we have primary, secondary, and tertiary alcohols. And how to identify whether the structure is primary, secondary, tertiary alcohol depends on the number of carbon atoms attached to the carbon with the OH group. So now let's take a look of some examples here. The first one I want to go through is primary alcohol. So for primary alcohol, the reason it's primary because we will look at the carbon right here, and since it's attached with the OH bond, and there's one more carbon attached to the carbon with the OH group, so therefore this is a primary alcohol because only one group attached to the carbon with the OH group. And if we look at the second example, the reason this is a secondary because if you look at carbon right here, it attached to the OH group. And there are two more carbon on the left and the right. So because there are two things attached to the carbon with the OH group, therefore this is a secondary alcohol. And finally, if we look at this example, I have carbon with the OH group, and then there are three more carbon attached to the carbon with the OH group. So therefore, since there are three carbon groups attached to it, therefore this is a tertiary alcohol. So this is how we identify whether the structure is primary, secondary, or tertiary compound. So finally, and before we end this lesson, I also want to go through one complex concept in IB chemistry, which is free radical substitution. So a free radical substitution is the substitution reaction in which the reactive intermediate is a free radical. So free radical, that means there's a electron, single electron attached to the chlorine or methane. For chlorine, it will appear that the free radical of chlorine will be in the initiation step, and for free radical of methane will be in the propagation step. So three steps will be in the free radical substitution. The first one is initiation, propagation, and then finally termination. So let's start with initiation first. So how does that work is the energy needed to do this is provided by the UV light. And so the UV light breaks the chlorine molecule. So for example, you can see there's I drew the structure right here. So the UV will break the chlorine molecule and then into two chlorine-free radicals. Okay, so this is by homolytic fission. So what does homolytic fission means? That means it will be like equal sharing of electrons because the covalent bond of the chlorine molecule has two electrons. And so one electron will go to this chlorine atom and the other one will go to this chlorine atom. So that means the electrons are equally split, and therefore this is what I call homolytic fission. And as you can see right here, there's Cl and then a dot right here. The dot right here indicates this is a free radical. So by doing initiation step, we will have two chlorine free radical species. Now, what happened next is in the propagation step, now the chlorine free radical will collide with methane molecule. As you can see in the mechanism right here, I have free radical of chlorine atom, and then it binds with CH4. And so now it becomes, what we get is the methyl free radical species is generated in this step. And again, it reacts with chlorine molecule to form a CCl bond. So you can see now, for example, let me explain the mechanism. This is a free chlorine molecule. It collides with methane. And then what I get is a free radical methane molecule. And then in this step, it will be repeat the step again. And now the chlorine free radical is what I get. And however, we need to remember is this is actually a cycle. So what happened in propagation is the cycle will start all over again. Once you get the free radical chlorine molecule, it will start over again, which means free radical chlorine molecule will again react with methane, and we will get free radical methane molecule, and everything will just keep repeating, and this is like a cycle. So what we need to do next to stop the cycle is by termination step. So what happened here is, remember from propagation step, we have two free radicals formed, which is free radical chlorine atom and free radical methane. So what we need to do is, we have these two things formed. So now we try to combine them. And so actually there are three possible outcomes. So the first one, the first outcome is if I combine two free radical chlorine molecule, I will get Cl2. Yes, and this two electron right here will form a bond, so therefore I will get a Cl2 molecule. And then the second step is when I have Cl free radical and methane free radical, this will form a bond, and I will get a CH3Cl molecule. Finally, for example, if I have two free radical methane molecule, what will I get? I will get a C2H6 molecule. So this is how we bring the chain reaction, which is like a cycle, to an end by termination step. So in summary is from initiation step, there's increase in the number of free radicals because now we have two Cl free radicals. And for propagation step, no change in the number of free radicals because I will still have one Cl free radical and one methane free radical. However, in termination step, the number of free radical will be decreased because now after I combine the free radical of chlorine and free radical of methane, there's no free radicals molecule anymore. So this is a summary of the free radical substitution. And this is also comes to the end of today's lesson. Hope you guys enjoy this video. And if you have any questions, feel free to let me know. Thank you so much.